All right, this is Unit 4, Section 3, Lesson 14 for Chemistry, Drop-in Molecular Views. So we're going to talk about more calculations for concentrations, and we're going to talk about comparing concentrations in general. So let's start and continue with our Kool-Aid example. So let's say I have 2 glasses of Kool-Aid here. One Kool-Aid has a concentration of 2 molarity. The other Kool-Aid has a concentration of 1 molarity. If I zoomed in and just looked at the Kool-Aid versus water molecules, in this example, I would have twice as many Kool-Aid molecules as I would this one. So this one would have a higher concentration of Kool-Aid. Basically, what you need to know from these 2 beakers is that the greater number for molarity, the more concentrated the solution, right? So the bigger this number is, the more concentrated it is, because you have more moles of solute packed into the same amounts of solvent, whether that be water or something else, but usually it's water. So let's do a couple of practice problems. So example number 1, which is more concentrated? Basically, it's asking which one has a higher molarity. Anytime you see concentrated, you're going to look for whichever number with a higher molarity. And remember, that's always in the unit M. Sometimes people write it in moles divided by liters to be more specific, but they're all the same thing, right? So in this example, I have 50 milliliters of a 2 molar toxin. So I have slightly less volume, but my concentration or molarity is higher. In this example, I have 175 milliliters, which is a lot more in volume, so I have a lot more Kool-Aid or toxin, whatever this is, but my concentration is 0.50 molarity. So if I'm looking at just concentration, then I'm looking for whichever one has the higher molarity, right? So capital M stands for molarity. This is a higher concentration, so it's a higher molarity. So 2.0 molarity toxin is the more concentrated toxin because the molarity is higher. Example number 2, calculating the moles in each solution. So in the last lesson, we calculated how many grams you can find in a solution given its molarity. So now we're going to calculate how many moles you can find. I'm just going to do problem A, and then I'll give you the answer to problem B at the end so you can try it on your own. So remember that anytime that I'm dealing with molarity, I need to know the equation that molarity, or capital M, basically means moles of solute divided by liters of solvents. So in this case, I have 0.5 liters. So this is 0.5, and my molarity is 2.0 capital M, and I'm looking for moles. So if I were to plug this equation, it would be 2.0 molarity equals moles. That's what I'm looking for. I'm just going to change this to the variable lowercase m and 0.5 liters. The next step would be just to solve for m. So basic algebra here. So I need to get m by itself. Here, m is divided by 0.5 liters, so I'm going to multiply both sides by 0.5 liters. And that will get m by itself because this crosses out. 0.5 liters times 2.0 molarity. If I plug that into my calculator, should give me 1 mole. And therefore, if I have a 0.5 liter solution of a 2.0 molarity solution, and I'm looking for how many moles I will have exactly 1 mole, right? For B, you can try B out on your own, but once you solve it, you should get 0.0625 moles, something close to that.